Importing a mold into simulation can be quite daunting with sometimes hundreds of individual components, but some of the new tools in Mold X3D can help to extract the useful components to reduce complexity and increase the efficiency for getting the analysis up and running. I'm Alex Baker, and welcome back to the Mold X3D Tips and Tricks series.
Since we have everything here, we can start going through and attributing these different components as different user-defined groups. So for example, I can take my user-defined group, add, and I can take this as a, let's say the core cavity blocks. You can also assign the color for these. So these right now have the orange and green colors. You can reassign that color if you want. And once you assign that user-defined group, that now becomes kind of a subgroup under the non-attributed category. And so I can hide those directly from there. Now I have my core and cavity inserts. This is where a majority of the cooling channel is actually going to be. If you were to turn these transparent, we'll do that in just a moment. You'll see that this is where the cooling channels kind of go around. All right, so I can right-click, edit attribute. All right, we're going to call these core cavity inserts. Maybe I'll assign a different color to them. Nice vibrant teal color. All right, so you can see that creates kind of a sub-attribution over here. Hide those. Actually, it looks like the designer was nice. They gave us the runner geometry. We can extract this geometry directly from the mold, but it's really nice if they give us the runner geometry. In this case, it's pretty easy. Just highlight the runner, and we can just attribute this right away. Call this the cold runner. No user-defined group necessary. The cold runner is a different attribution than the rest of the components. All right, and then you can see the runner itself is attached to the cavities. It's not uncommon for the cavities to be included in the mold. It's a little bit uncommon for the runner to be there, but the part should absolutely be included in the mold. All right, so we'll go and attribute these guys as the part. And that's it. Everything else is fluff. Everything else is information that we don't need in the simulation. And it might sound a little bit weird, but once you have everything that is important hidden, you can just box select everything and delete it. All right, now all of our important components are hidden. I'm just going to show all of those. All right, so we have our core block, core insert, cavity block, cavity insert. We have our two parts in there. The only thing we need these core and cavity blocks for is for the cooling channels. We have a nice tool that allows us to extract those cooling channels automatically. So you don't have to like extract the surfaces or anything like that. We're going to highlight one of these blocks. All right, we're going to go to Tool, More, and Extract Channel Wizard. All right, and the way this function works is it's going to ask you what channel. You can see that it's kind of highlighted a bunch of these channels in orange. These are the channels that I could extract. And so we can see the inlet of our channel right here. You can kind of see it through the surface of the mold. All right, and so I'm going to select kind of the inlet here, this guy, as well as the main channel itself. So you can see it highlights in the dark orange color. I can also highlight the inside here. You can see it highlights all the way through. You can see these red feature lines go all the way through and then down to where the cavity block contacts the insert. And I'll do the same thing on the insert to extract the channel that goes around the parts. While I'm here, I can also extract these two. I'm going to hold the shift button while I'm doing this to make sure that I'm selecting everything. All right, so what this function is going to do is it's going to extract the solid of this channel. All right, so it's going to give me a solid geometry that represents the negative of this channel. And so when I press the green check mark, that's exactly what it does. So it creates a solid of that channel. So if I hide my cavity block here, you can see it has created the negative of that channel for me. I can temporarily assign these as cooling channels. I'm going to get rid of those for now. All right, so if I turn this cavity block here transparent, we can see the channel that we're trying to extract. So you can see that it kind of goes down, around, and then back out. This channel extraction is actually going to be really, really straightforward. We're going to use that same function. I'm going to go to Extract Channel Wizard, select this block. All right, and it already identifies that this entire channel is extractable, so all I have to do is click on it, and you can see that it selects the entire channel. I don't have to do multiple clicks or anything like that. You just do one click, extracts the entire thing, check mark, and it extracts the negative of that channel. Now, interestingly enough, and this is kind of a cool interaction, you can see that before I attribute this loop here, you can see that it's identified this as loop 1 over in my attribution menu, and this over here as loop 2 because they are disconnected from one another. Once I assign this guy here as a cooling channel, you can actually see that it automatically associates all three of those together. And so when I go to mesh this, it will make a continuous mesh through all three of these. If you wanted these to be one singular solid geometry, you can absolutely do that by unioning them. That'll be up in your tool tab. And it is this guy right here. I can union all three of those together. And now they are one singular geometry. I can do the same thing on the bottom side. The bottom side actually has a very, very similar cooling channel structure. All right, so I'll use that Extract Channel Wizard. Select that core block. Make sure to do the same exact thing on the bottom side as I did on the top side. Extracting those channels. All right, we can hide this guy. Attribute these cooling channels as such. And hide those cooling channels for the time being. All right, and then I just need to grab the cooling channels through here. Once again, we can see if we turn these transparent, we can see that cooling channel kind of wrap up around and then back out. So do the exact same thing. Extract Channel Wizard. Select this surface here. Check mark. You can hide this guy. And assign this cooling channel as such. You can see that all three of those, once again, have been associated with one another because of that perfect interaction. But if you want to, once again, you can union all three of these, and they become one singular geometry. All right, now that we have everything extracted, now it's just a matter of applying a couple boundary conditions, give ourselves a mold base, and then we're good to go. All right, so we need 3 boundary conditions here. 3 types of boundary conditions. First of all, we need the melt entrance that goes on top of the runner. And then we need our inlets and outlets for our cooling channels. We can apply both of those over in the Model tab. The melt entrance should be easy enough. I can just use the automatic melt entrance function, or if I want to guarantee that it's up on the top surface here, I can use specify face. I can just click on that surface, check mark. See, it creates that boundary condition over here. Now for inline and outlet, I will need a mold base established already. And so I'm going to use this mold base function here. Now the cool thing is it kind of finds these outermost surfaces. And as long as these outermost surfaces are all connected to one another, they will automatically be on the mold wall, and I don't have to worry about that constraint. A potential issue, not something to really be concerned about necessarily, but just something to be maybe aware of, is that these cooling channels, it will find all of the flat surfaces and it'll map the mold base wall to those outermost flat surfaces. This isn't actually a problem in the analysis, but it will maybe look a little bit weird on the mesh, so just be aware of it. I might want to reduce the height. The height looks a little bit too extreme here, so I'm going to use the blue arrow and change the overall height down to, let's say, 200. All right, now the inlets and outlets, you can see that those are active now. We can't use the automatic function. The automatic function will only work for line-defined objects, which we could create lines. We could extract the center lines from this, but I think it's a little more tedious than necessary. So I'm going to use the add inlet function. All right, I have one inlet here, and then I have one outlet here, one outlet here. And in order to apply these inlets and outlets, I'm going to need to find the center of this surface. So I'm going to use my center snap down here. Find center 1, center 2 for both of my inlets. And then for my outlets, same thing, center 1, center 2. Every cooling channel needs at least one inlet and one outlet. All right, and from here, I am all good to start meshing it. All right, so I'll go mesh, generate, and we'll just generate it all the way through. All right, mesh generates. And this is what I was mentioning. It might look a little bit weird that there's some exposure to the outside wall. It's not a big deal from the simulation side, but it just might look a little bit weird that there's some surfaces poking out the side here. All right, saves all right. And then we can just go through and select our material process, and we'd be good to launch the analysis. Now, the real process might be a little bit more tedious than what I showed here, but generally speaking, that's the procedure. Is we'll find all these negatives, be able to extract those, and then it's just a matter of attributing and meshing. I think the most tedious part of this is organizing and sifting through all of these solids. That's probably the most difficult part of it. Once you have all of that organized, then it's just a matter of extracting the information that you need.